This video is about, it is one application of a parabola, and this is from your textbook, and it reads, a headlight is being constructed in the shape of a paraboloid, which is a 3D parabola, with a depth of 4 inches and a diameter of 5 inches. Determine the distance d that the bulb should be placed from the vertex in order for the beam of light to shine straight ahead. So, this is the picture they give us, and so the orientation of the parabola is right and left. So what I am going to choose to do is think about what the standard form of parabolas are. So for parabolas that face right and left, those are y squared. Y squared is equal to 4cx. This is the standard form of a parabola where the vertex is at the origin, because I don't have a h and I don't have a k. The thing about this word problem is I get to choose where I want to orient my parabola, so I don't want to mess up the nice picture they have. I will draw my own so you guys can see. I'm just going to kind of copy this. I'm choosing to orient my parabola to the right like they do. And at the end of my parabola, since it's 3D figure, there's a circle at the surface. So the diameter they're talking about is right here. The diameter of the surface is 5 inches. Where will they place the bulb in order for everything to shine straight ahead? That will be at the focus. So what they're asking when they say what is D, that in our language is C. What is C? C is always the distance from the vertex to the focus. Or if it were an ellipse, it's the distance from the center to the foci. That's what C is. And the same for a hyperbola. Okay, so the vertex is at 0, 0. That means we have this equation. How can we figure out what the value of C is? That's the job. They told us that the diameter is 5 inches, so that means halfway across the circle is a radius, which is half of the diameter. So that means from here to here would be 2.5, half of 5. So that means, since I've put this on sort of a XY axis so I can sort of talk about it, then the point right here on my parabola would have the coordinates. I'm going to go to the right, the depth, which is 4 inches. So x would be 4 and y would be the distance of the radius, 2.5. Also, we could identify another point on our parabola down here. This one at the edge would be 4 to the right and down, negative 2.5. What will we do with these points is we'll plug them into the equation that we wrote down for our parabola and solve for C. So you could use either one, this point or that one. It doesn't matter. I'm just going to choose the positive one. So my y value is 2.5. I'm going to put that in for y. So 2.5 quantity squared is equal to 4 times C times my x value, which is 4. So I have my calculator and I say 2.5 squared is equal to 6.25. 4 times 4 is 16C. I'll divide both sides by 16 and I'll get that C is equal to 6.25 divided by 16 is 0.39. So they should place the bulb 0.39 inches or about 0.4 inches from the vertex in order to get the beams of light to shine straight ahead.